Hello friends and welcome back. So in this session I am going to show you how we can implement the Tomcat in Docker. Okay, so this is the complete end-to-end action plan that I am going to follow. Okay, for this implementation. Okay, but before I explain you the complete end-to-end action plan, along with I will go for the execution. Okay, I will explain you some a small concept of the Docker. If you do not have some knowledge of Docker, okay, so I will give you some overview of Docker and then I will jump into the this particular lab exercise so that you will have a better understanding. Okay, so let me first explain you what exactly is the Docker. So Docker is called as a containerized solution. Okay, Docker is called a containerized solution. Containerized solution. Now, what does it mean? So if I talk about traditionally, okay, now if you want to build a particular machine with your application, with your softwares, and then along with the dependency. So what you do exactly? So first you install the software, right? And after installation of software, once your installation is complete, then you deploy your application. Then you deploy the application, whether you have a website or whether you have some Java-based application which you are going to deploy in some your application servers, right? And along with that, you may have the dependencies, the software dependencies. Okay, so these dependencies could be related with the OS level. Okay, so multiple times we have the library files. Okay, so these library files could be OS related. For example, you are on a Unix based systems. Okay, so in Unix based system you will have a particular library files that is specifically required for your software to run. Okay, so many times when we install multiple application servers or database or any other software, okay, they have the dependency on some OS level library files. Okay, and along with that there could be some other dependencies as well that we copy in some different folders inside the operating system. So in a nutshell, whenever we talk about the complete end-to-end dependencies and about the implementation of our applications on software, so mostly what we have the our software, and then we have our applications, and then we have the dependencies. Okay, so we have to ensure that software application and dependencies are in place. Okay, so if you are going to build one environment, or maybe you are going to build a multiple environment, production, non-production, development, testing, quality, pre-prod. Okay, so everywhere you have to ensure that same set of software, same set of dependencies are copied. Otherwise, multiple time it is happened that when we build the environment, something get broken between the multiple environments. We find that something is working in the development, but something is not working in the some other environments. Okay, because of the dependencies are broken. Okay, multiple times we do not copy the dependencies, or sometimes there could be some different operating system versions and then something got missed. Okay, so we have to ensure multiple things. Now when we talk about the Docker, okay, so in Docker what we do, we package all these things inside a particular image, software application plus dependencies, that will be part of a single package. Okay, now suppose that this is a package. Okay, so this package you consider as a like zip file. You know that we have a zip file which contain the multiple component with zip, right? In the Linux we have a tar file. So this package file you can consider similar to the zip file or the tar file. Okay, so what we have inside this particular package, so in this application, in this package we have our applications, then we have our software. Okay, and along with the application and software we have the dependencies as well. Okay, and these dependencies also contain in this image a lightweight OS image, lightweight OS image, and this lightweight OS image will be Unix based. It could be Debian, Linux, or any of the Unix based operating system, but this will be a lightweight. It is not the complete operating system. Okay, very lightweight, and this lightweight OS contain all the dependencies that is required for your application to run. Okay, so now what will happen in that case? My applications, my software, my all the dependencies, including the lightweight operating system, inside a single package. This single package. Okay, this is called the image in the Docker. Right. So this is a package which is I'm calling as an image. Okay, it has all everything that is need my application to run. Okay, so now if I'm going to configure multiple environments, so what I need to do, I need to just take this package, and this package need to be copied in my different environments: development, testing, quality, pre-prod, prod. Everywhere I can use this package because this package has contained my all the dependencies and applications which I need to run. Right. So now you can see these dependencies removed. I don't need to configure anything manually. It is a one-time activity, and one time setup is completed, you just take this image and copy it to the multiple environments. And once my image is ready, so what we do, we run the container. Okay, we run the containers, and these containers are based on the image. So containers are the runtime component of the image. Okay, so because this image contain everything, so based on this image we can directly run the containers. Okay, so these containers, as I said, is the runtime component of this particular image. Right. So now, at least I hope if you do not have any prior knowledge on Docker or containerization, or if you are confused anywhere, so you should have some clarity. Like, what is the Docker? It is a containerized solution where we create a package which contain your complete application software, and along with the dependencies with a lightweight operating system, which is called image. And based on image, we spin up the multiple containers. And containers is the runtime component of your image. Okay, so you can consider Tomcat container as a running processes of a Tomcat, right? So whenever we run the Tomcat, you can see the process of that particular Tomcat, right, with the help of ps-ef command in the Linux. So container you can consider as a runtime component, or it is a process of the running Tomcat. Okay, so now let me go back to the actual plan. So this is our action plan, okay? And what is there in the action plan? I will explain you step by step, so that you will have a complete understanding, okay? So what we learned so far, that we create an image, and based on the image we start the containers, correct? So that means first we have to create the image. So image will contain the Tomcat software, right? Because image contain everything. So very first thing, we will create a project folder, or you can create it with any name, whatever you want in your local system, okay? And once your project folder is created, okay, we are going to create a Docker file. So Docker file will contain all the syntax and command that is required to create an image. Okay, so this is the main configuration file, Docker file, with the default name is Docker file D capital. Okay, so whenever we run the command to build the Docker image, okay, it always look for the Docker file, a file with the name of Docker file D in caps in the current directory. Okay, you want to override that file name with some different file name, then we have option, we can give the -f and the different file name. But traditionally this is the default file name, and your Docker always look for this file in the current directory. Okay, and this is the main configuration file. Okay, so if you wanted to have expertise on the Docker, then you should have understand what is Docker file, and whatever the syntax and commands that we define inside the Docker file. Okay, so here I have given few commands, okay, to create the Tomcat image. Okay, and what are the syntax that I have given in the Docker file? The very first thing is from. Okay, so this from specify the image, which image you wanted to use. So we are going to use the Tomcat image. Okay, so by default, right, when we specify from, okay, then from where it is going to create the image. So from we have defined Tomcat colon 9.0. So this is the image name, and this is the tag. Okay, so if you define this tag like this one, image name, and then the particular version of the image, okay, so by default your Docker look for the Docker public repository. Okay, so that means when we define like this in our Docker file, it will always look for this particular location. Okay, this is a hub.docker.com. So in this hub.docker.com, this is a public repository of the images. Okay, there are multiple images are already there, okay, which are public, and anyone can use that one. So now we are using the Tomcat, so let me search for the Tomcat here. Okay, and we are going for the images. Now you can see this is the Tomcat image. You can see the name. What is the name? It is a Tomcat, right? And the same name we have given here in the from command, Tomcat. Okay, so by default it is going to look for this public repository of the Docker, and from it will go to this Tomcat. Okay, and inside this Tomcat we have a multiple images. Okay, multiple versions of the Tomcat, right? 11 and then 10 and then 9. Multiple versions are there, and then corresponding tags are, you can see the corresponding tags. Okay, and this is the command they have given. If you want to pull the image, this is the command to pull. Okay, so now what I have used the Tomcat and the tag 9.0. Okay, so this has taken the 9.0 image of the Tomcat, and from this section you can see there are a lot of tags are here. Okay, so it has automatically picked up the tag 9.0. Okay, so this is the Tomcat image name, and these are the different tags. So whatever the version of the Tomcat you would like to install in your image, so specify the Tomcat package name, image name, which is the Tomcat here. And for tag, whatever the version that you would like to install, you take the tag name from here, okay, and specify here, and your image will be created based on that particular image. So this is the image. So now this is a public library, right? Anyone can download from here. So here in the from we have defined the public library, but in many organizations they do not prefer to download the publicly available images. They create their own registry. Okay, so if you have such situation where some organizations have their own registry, okay, so here we specify the complete path of the registry to download it from the private registry. So as of now it is downloading from the Docker Hub public image. Okay, then copy command. So now we what we want, once my image is ready with the Tomcat, I want to deploy my code, right? So copy command will copy the file what you have specified from your local system inside the web apps of your Tomcat. So this is the default installation location of Tomcat. Okay, and in the Tomcat we know that we have a web apps folder, and whenever we want to deploy any application we just copy the code file in the web apps folder, right? So this will create the image, and as soon as the image is ready it will copy this particular code file from my local system to web apps. So that means this will deploy my code file once my image is ready. Then expose 8080. So this is going to expose the port. Okay, so because we know that the services are running inside the container, right? And container is running inside the Docker. So to access the services which is running inside your Docker, okay, you need to expose some port. Okay, that means whenever you want to access the application outside the container, for example, I will start the container and then I will try to access the Tomcat from my local system laptop, right? So my laptop is having a separate network, and then Docker is having a separate network, and Tomcat is running inside the container, right? So to access the services which is running inside the container, we have to map a local port with the port of the services which is running inside the container. Okay, so because the Tomcat default port is 8080, right? So if I want to access it from a local system, I need to map some local port as well. Okay, so this is the mapping that we are doing, and here what we are doing, we are giving the exposure to this particular Tomcat services which is going to start here on port 8080. So your Tomcat is going to run on the port 8080. So cmd command is used when the image is created. At last, if you want to start any of the services, then we give the cmd command in the Docker file. So here you can see we have given the catalina.sh and then run. So what this will do, first it will download the Tomcat image, then it will copy my code from my local system to the web apps directory, then it will expose the port of this Tomcat 8080, and then it will start the Tomcat, right? So this is all, like it will download the image and it will deploy your code and it will start the services. So this is the work of your Docker file, and based on that we are going to create the image file. So to create the image file, syntax is docker build. So docker build command is used to create the image, and then -t, that means tag. So every image that we create, we have to give the image name and along with a tag, whatever the tag you want to specify. So this is the image name that we have given, digitalk-tomcat, then colon v1. Okay, so v1 is the tag that we have given for this image. So now this image is going to be identified with the help of name and corresponding tag, and then dot. So it will look for the Docker file inside your current directory. Okay, so once your image is created, we can run the docker images command, and this docker images command can list all the images that is there in your system, right? So here we are going to create an image with the name of digitalk-tomcat with tag v1. So this command will display this image as well along with whatever the images that is there in your system. So once your image is ready, we have to spin up the Tomcat, right? We need to start the Tomcat. So for that we are going to spin up a container. To spin up a container, the command is docker run. Okay, so you can see here docker build command is used to build the image, and docker run command we have used to run the Docker, right? Then -t, that means in the detach mode. So when you run this command, it will automatically come out to the prompt, okay, from wherever you ran the command, because if you not specify -d, so you will not come out from at the prompt, and then whenever you are going to close the window, your container will be stopped. So you have to give -d for detach mode, and then you have to specify a name for your container, whatever the name that you want to give to your container. Then you need to expose the port. Okay, so this port is the service expo, right? This is the Tomcat port. So we have given the expose 8080. So we are running this Tomcat on port 8080. So this is the port inside the container, right? Now we want to access this particular services inside the container on port 8080 from my local laptop, local system. So I need to map a local port. So I have given the local port also 8080. You can give any available port from your local system. It's not about only 8080. So what I did the same port for my local system as well, and it is going to map to the 8080 port which is running inside the container. Okay, and this container, we are going to run the container, and this container will be based on some image, right? So this is the image that we have created. So in this command, at last I will give the name of my image, so that this command will understand I need to start this particular container which will be based on this particular image. Okay, so once it starts, the service has started, so you can verify it, so you can access your application from the browser. So this 8080 port is the port which I have specified here, my local port, which is mapped with this particular port inside the container. Okay, you can access the application, then you can run the different command like docker logs command you can run and give the name of your container. Okay, so this will give you the logs of your container. And then we have the multiple other command like you would like to go inside the container, okay, to validate some configurations or anything, then this is the command docker exec-it and then container name and the shell, bash shell. So this command you can give and you can go inside the container to look for the process or look for the different configuration files. Anytime you want to stop the container, we have a docker stop, docker start command. And if you are done with the lab exercises, you want to free up the resources, you have the docker rm command to remove the container and docker rmi command to remove the image. Okay, so this is a net exercise that I am going to execute as of now. And apart from that, we have some different scenarios as well. Okay, different scenarios like immutable Docker, like where we have everything inside the image. Okay, sometimes we want that some of the configuration outside the Docker or outside the image. We don't want them to be inside the image. There are certain reasons of that one. Okay, there are a lot of pros and cons and reasons for that one. So that I will explain once this exercise is completed. Okay, then we'll jump up into the other exercises where I will explain you the some different scenarios as well that we use for the implementation of the Tomcat. Okay, and you may see the different scenarios in the different organizations based on their requirements. Okay, so this is one of the basic use case what I am showing to you here. Okay, so hope it is clear to you. The action plan is clear to you. So let me show you with the execution. So first I will create a folder in my local system. Okay, which I will call as a project folder. Okay, so let me create a folder. Okay, new Tomcat Docker lab, right? And after that, the very first thing I need to create a Docker file, okay, which contain all the syntax that I have explained. So let me give the name. So I have to remove this .txt, okay, once the contents are copied. So I will take all these contents, I will paste here and I will save, close, and I will remove .txt, okay, because this has to be with the on. Okay, so what it will do, it will copy this local file, my bank.var. This is a code file. So I will copy this inside my same folder here. Okay, so this will look for this particular file in my local directory, project directory, and then this file will be copied inside the image, right? This one. Okay, so now I have created Docker file. I need to run this command docker build, okay, to create the image. So what I will do, I will quickly go to my command prompt, okay, and then I will run the docker build command. Okay, so this is going to download the image from your system. Okay, so let me see error. Okay, it is saying that the copy my app. Okay, it's not able to find the my bank.var. Let me see what is the mistake I have done. Okay, copy and then expose. Okay, the file is there inside the directory. Let me see. Okay, I have given the wrong name, I think. My bank.var. So this has to be my bank.var. I have given the my app. Right, so let me go back and then fix it. So now let me run it again. Okay, so this will it's still taking. Okay, I have changed in my code, but I have not changed text file. I have not changed here in the code. Okay, so I will update this file here and this mybank.var. Save and then close. Okay, so now this is going to download the Docker image. Okay, Docker Tomcat image. Okay, from the Docker Hub registry, which is referred as the docker.io. So this docker.io is the Docker Hub registry. Okay, from where it has downloaded this particular Docker image. Okay, this is a image, and after that you can see once the image is there, it copied the my code as well, right? It ran this particular command, so it copied this my bank.var to the web apps directory. That means the image has been created, okay, and our code has been deployed after creating this, right? So now our image is created. Okay, so what is the next thing? I need to run the container, which is the runtime component of the image, right? So let me take this command, go here, and then run the docker run. Okay, now you are at the prompt. Okay, so because we have used the -d detach mode. Okay, so now if you want to check the images and the your containers. Okay, so docker images. Okay, so docker images will list all the images that you have in your system. So if you see here, this is the image that we have created. So this is the name, digitalk-tomcat is the repository name. Okay, and this is the tag v1, the same we have given, right, when we ran the command to build the image. Okay, so you can see here, this is the command we ran to build the image. So this was our the name for the build we have given for the image, and the version was v1. Okay, and this is the tomcat, and this is the version, and there is a great importance of this tag in the docker. Okay, I will explain in the next sessions where we have a different scenarios what is the importance of this tag, right? So now this is image, and then you want to check the container. Okay, so if you run the docker ps command, this will show you all the running containers. Okay, so this container, you can say this is the container which is based on this particular image. Okay, this is up since last 53 seconds. This is the port forwarding, this is our local port, and this is the port inside the container. Okay, and to access the your tomcat application, whatever the deployed, so we have deployed the mybank.var application. To access it, I need to use the local 8080 port, which is mapped with the 8080 port which is inside the container, and each and every container or images will have a corresponding id. So this is the container id, and for again for image, you can see this is the image id, right? So for each and every component you will have a corresponding id. So now we have created the image based on the docker file, and then we have spin up the container based on the particular image that we have created. That means our application has been deployed and Tomcat is now started and running. Okay, so now we need to test it. So you can go to the browser, localhost colon 8080, and then context of the application, which is my bank. Okay, now you can see we can able to access the application. Okay, so this application is running inside the container on the port 8080. Okay, we are accessing the port 8080 from my local laptop as well, because we have done the mapping 8080. Okay, so suppose that in the docker file, if you have given some other port, like let me go back and show you. Okay, sorry, when you run the container. Okay, so when you run the container, if you suppose for this 8080 you have given some other port like 7777. Okay, so what will happen, this port will be your local port, so this port is going to map to 8080, so you have to use this 7777 port, not the 8080. So now few other commands. Okay, so I explained you can use the docker images command to list out all the images. You can run the docker ps command to run all the running containers. Okay, now suppose you want to go inside the container, running container, you want to see the process inside the container, you want to check some configuration file inside the containers. So for that we can run the command docker exec-it. Okay, and then your container id. So this is our container id, which we can check with the help of docker ps command, and then shell, in which shell you want to go, right? So I given the best. Now you can see we are inside the containers. Okay, so here you can't able to run all the commands because this container has a lightweight os image. So lightweight os image means it has some limited content. It's not a complete os where you can run every command. Okay, it has some limited commands and some limited functionalities that is only required to run your application. That's why it is called a lightweight your lightweight os. Okay, and now because we are inside the container, so if you want to check the location where we have copied our code, so this is the default location, right? So you can run this command now inside the container. Okay, and if you list, you can see this is a mybank.var file that has been deployed. If you go one step back, so here this is the Tomcat directory where you can see the multiple different configuration files that is there in the Tomcat. Like for example, you want to view some configurations, you can go to conf folder. Okay, here you can see there are the different configuration files are there. Okay, but you may not able to run certain some commands. Okay, so like I am giving more command, it is accessible. Okay, I can give the more command and I can look up for the content. Okay, similarly you can try for the cat command as well. Okay, so cat is also there, you can also run the cat command to view the content. Okay, now suppose you are going to run the web.xml vi. Okay, so vi will not be fine because it doesn't have the editor. So editor is not a kind of a functionality that is required to run your application, right? So that's why editor is not there, it is not part of the lightweight application server. Okay, so this way you can validate the different configurations. Now the important point which we are going to cover in the further exercises, where we have some other different scenarios, the way we implement this docker and tomcat in the organizations. Okay, based on the different requirements. So we do not do any changes in the inside the container. Okay, because right now we are inside the container. So if you modify any file here, okay, so this modification will be applicable for this particular container. But anytime if you delete this container, okay, and you spin up a new container, then your all the changes will be lost. Any changes that you do inside the container will be lost. That's why we never do any changes inside the containers. You can go inside the containers. I have shown to you how to go inside container, how to validate the configurations, and then you can how to edit the files. But you should not do any changes inside the containers because that will be lost. Okay, so that's why we have some different kind of a approach. So whenever we want to do the deployment, or maybe whenever we want to do the configuration changes, so how this is going to be reflect, how your new code is going to be deployed whenever you are doing the any code modifications. If you want to do any modification in the configuration files, then how we do the changes in the configuration file. So there are different approach for that one, for the implementation. So how we create the Docker file and how we implement the configurations and code files, okay, whenever we have a new changes. So this I am going to cover in the next exercises, okay, where I will show you some two different scenarios, and this will give the complete clarity how we implement the Tomcat in Docker in the industry at the real time. Okay, so now if you wanted to clean your exercises, so you can just run the Docker ps command, and then you can stop the container with the help of stop command, Docker uh, Docker stop, then give the name of your Docker ID, container ID. So once it is stopped, so you can run the Docker rm command to run this particular container. So you can now check with the Docker ps command, it will not be there. Right, now similarly you can delete the images as well. Okay, so you can run the Docker, and for to remove the image we have RMI, and then you can give the ID of your image. Okay, it is deleted. So now if you list out again, then you will not see our Docker Tomcat image. Right, so now it is hope to you how clear to you how we implement the Tomcat in the Docker, and then you should have some clarity on the how we actually create the images files, container files, how to run the containers, and what is the fundamental concept of the image and the containers, right? Which I have explained at the beginning of this session. Okay, so now in the next session I am going to explain you two more scenarios, okay, that we mostly use in the industry for the implementation based on the different requirements.